Okay. We all remember a hypothesis test, do we? You should, because this is going to keep coming up over and over until the end of the semester.
This is chapter 11.
Yes. So we did a confidence interval for difference means. That's what we did before we started the proportion. And we discussed two different cases. One where the degrees of freedom was the minimum of n1 minus 1 and n2 minus 1, right? Remember? It's coming back to you. What was the other one? What was the other one? It was pretty scary. You know, there is, think of it this way, there is a juice named after that degrees of freedom. Welch, see? Think of, Welch's juice. So the second approach is the Welch's degrees of freedom, or the Welch's test. So we could do the same thing, use the same set of formulas to come up with two different tests for the difference in means. How are things going to change? So what do we need in order to have a test or to perform a test? The very first step is the definition of the test. Yes? Step 2. What do we need in step 2? Level of significance. Oh, it is a probability of type 1 error under the null. What is our typical third step?
Test type.
Huh?
The test type.
We can identify that over there, right? But perhaps I should write that. Define H0, H1, and the type of test, which should be left, right, or 210. In order to verify a hypothesis, what do we need? The most important thing in statistics.
Test statistic.
True. But in order to find the test statistic, what do we need?
P-value.
P-value.
Oh.
You're missing the most important part.
volume?
No.
No? Should I just keep throwing words?
Yeah, that's exactly what you're doing, so you continue. What do we need to verify a hypothesis?
Mean.
Mean, where do you get the mean from?
Sample.
Sample, thank you. You need a sample first. So the next step is to collect a sample, or samples, and once you have that, that is going to help you get the mean, standard deviation, and all those wonderful things. Right? So compute the test statistic and identify distribution of test statistic. By identify, I mean I'm going to give you that information, you just have to bring it back from your memory. So when we did means, we had two different cases. One was pooled, the other was not pooled, correct? And in the pooled case, we kind of did it in two different ways. One, where we simply directly used the degrees of freedom, using the minimum of n1 minus 1 and n2 minus 1. The other case is the Welch's case. We're simply going to do the Welch's case for the pooled. This is the formula for the test statistic.
Can you write it on that side or up on here?
Over here. Yeah.
Yeah, just see it.
Look at that thing. Okay, so I'm writing this here because this formula is the same over there also. Okay, it is the same formula, so I'll write it over here. It is the same formula. You can go back and look at the video also. But what is the difference then? The difference has to be in the standard error. So the formula for the standard error will change. The formula for the degrees of freedom will change. Good? That is the difference between these two. I'll just put that to be the pooled case. This is what I want you guys to do before you come to class on Thursday. Look at the formula for standard error in the unpooled case when we found the confidence interval for difference in means. What are we going to look at?
The standard error.
Standard error for
Unpooled
unpooled case. Naturally, look at the standard error for the pooled case when we found the confidence interval for difference in means. In addition, look at the distribution that we use for the unpooled case and the distribution that we use for the pooled case. I'll give you a hint. Both of them are t-distributions, but the difference was in the degrees of freedom that we used. They are different formulas, okay? I just want you guys to read so that when you come back, you have a better idea to link confidence intervals with hypothesis tests. Huh? That's exactly what I said. The same formula, but it is going to differ in the standard error, which I will do next time. If you have any questions, talk to me. If not, I will see you on Thursday. That should work. Okay. Hypothesis test for difference in means. I mentioned two cases, pooled and not pooled. And I also mentioned that the process is entirely the same except for the standard error and the distribution that we use. I asked you to look at the standard error. One is that simple formula. We will do that here. And the other is the Welsh formula and unpooled variance. I'm going to give you a very short assignment. It is in the textbook. It's like 4 pointers, or maybe 2. The repeating theme is that in this case the samples have to be independent and they have to be the population they have to be independent and normally distributed. Only then we could use this test. But some books give other assumptions, so do read the assumptions. It's like 3 or 4 points. In all my examples, I'm going to assume that the assumptions hold true. Good? Yes?
Are those the same assumptions we talked about with the confidence intervals and the other difference in means?
Good question. No,
Okay.
they're different. Okay, who wants to give me a good example for a test or a test to determine difference in means? So we need 2 independent populations and we're going to compare the average of one to the average of other. Okay.
And we're still focusing on independent populations?
Yes, independent populations. How many of you like sweet tea? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. How many of you like Coke or Pepsi? Can't be the same people. Okay. let's redo this. Best drink, okay, that you would order, your favorite one. How many of you's favorite is sweet tea? 1, 2, 3, 4, 5, 6, 7, 8.
Is it just between Coke and Pepsi and sweet tea? Or is it like any drink?
Between sweet tea and everything else.
Okay.
So you all like sweet tea. Okay. So the others, you just don't like sweet tea. So different population. Population that likes sweet tea, population that doesn't like sweet tea. Okay. We want something to measure among these two populations. An average of interest. What should we measure? It could be the amount you spend on movie theaters, or movies, or the amount you spend eating out. Which one should we go for? You come up with one. Amount of sleep. It feels like I'm taking the class.
The amount we spend on groceries.
The amount we spend on groceries, okay. Per week, right? Reasonable.
What was that?
Per week?
Yeah.
Okay. Should we do greater, less than, or equal to, or not equal to?
Creator.
Greater.
What does the DYI stand for? Up at the top.
Do it yourself.
Oh,
Oh, you guys don't know.
Really?
So back in the day, I don't know if it's still, oh, it's
Still
DIY.
that makes more sense.
Yeah, for a minute, I was dyslexic.
Are we specifying groceries per week or per month?
Oh, wait. That'd be done. Is that channel still there? The do-it-yourself channel? Whatever it is. I'm picking up simple examples so that you can get the concept easily. Who doesn't like sweet tea? Those people. Do we have two averages? we have the average amount spent on groceries by students who like sweet tea. It's average one, or mean. The average amount spent on groceries by students who do not like sweet tea. Average 2, mean 2. Which one should we call population 1 or sample 1? Or does it matter? It doesn't matter. So we'll just call the first one to be mu1. We'll call this mu1. And we'll call that mu2. So we would like to use an alpha of 0.1 and a t-test without pulling the variance.
So what does it mean for a variance to be pooled or unpooled again?
Which is,
What does it mean for a variance to be pooled or unpooled? I forgot.
remember when we don't pool, we treat S1 and S2 separately. And when we pool, we combine them using that formula and call it as SP squared. I'll do an example of that too. Okay, you said they like sweet tea. You cannot like the rest. Okay, so you absolutely like sweet tea. Okay, how much do you spend?
$25 a week.
Probably
50? 50?
Yep.
50,
1 to 5 or 5 0?
5,
100? 25? 30?
50.
30?
25.
25? 16? 1 6 or 6 0?
60.
Is that it? Okay. Now the others who do not like sweet tea,
Like 55.
55,
50.
50.
45. I'm 45. 45. 75. 80. 30.
These are approximate amounts anyway, so. If you buy into that organic craze, this is going to be doubled. Who likes organic stuff? And you spend under 60? That's surprising. Good. I'll give you a minute to calculate. What is the very first step that we should do when we have a test?
Define the null and alternative.
Define the null and the alternative. The null here is the average amount spent on groceries by students who like sweet tea, the first average. The second average is the average amount spent on groceries by students who do not like sweet tea. So what is the alternative?
One is less than, alternative,
Mu1 is
greater than.
greater than mu2. Over here,
Less than or equal
your book is dead set about using that. Either is okay. I'll be careful next time. Alpha is 0.1. It is the probability of type 1 error under null, right? In other words, given the null, which is mu1 equals to mu2, the amount of error, false positive, rejecting the null, that we are willing to tolerate is 10% or less, so we set a level of 10%. We have the data. Since we have the data, we could find the mean, we could find the standard deviation. We know the sample size from the sample itself. So use your calculator and use the data here to tell and get me the mean, the standard deviation for the first sample, the mean, and the standard deviation for the second sample. The next step is to find the test statistic. And that test statistic is T. X1 bar minus X2 bar minus mu naught divided by SE. SE is, take a guess, standard error. Now, do we know X1 bar? Yes. We know X2 bar. Standard error, I'm going to give you a formula. We do not know what mu naught is. When we did a one sample test, we knew what mu naught was just by reading the question or looking at the claim. If it said mu greater than 5, then mu naught was 5, right? Mu less than 2, then mu naught was 2. Here, we don't know what that number is, because the way we wrote it, the definition, we aren't able to see. But if I rewrite the claim by moving mu2 to the other side, what will be on the right-hand side? Algebra people? 0. Right? These two statements are equivalent. Do you agree? They are one and the same. All I did is move this mu2 to the other side. I have 0. And that number is mu naught. Mu1 minus mu2 is difference in means. for me to say mu1 is greater than mu2 is the same as saying the difference in the means is greater than 0. Same statement, written in different ways. So mu0 here is 0. We can easily find x1 bar minus x2 bar, which is 48.33 minus 50.56, which is 3, 2, 2, and negative.
So does that mean mu0 is always going to be 0, or is that just for this problem?
For this problem. And we have a formula for standard error. And that is the formula. Does that come to your mind? We've done this before. So we have the test statistic, and once we have the test statistic, what is the next step? The distribution is T, with df equals to the minimum of n1 minus 1 and n2 minus 1. And we know what n1 minus 1 and n2 minus 1 are. In this case, they happen to be the same. So what is the minimum of 8 and 8? 8. So in our case, it is simply 8. This is a right-hand test. Agreed, mu1 greater than mu2. So the rejection region has to be on which side? Left or right? Right. And that area is going to help us determine what the critical value is. In this case, it is T, and the area below, 1 minus alpha. We don't divide it by 2 because this is not a 2-10 test. And df. How do we find that critical value? What function to use?
Inverse T.
Inverse T. So go ahead and plug in inverse T and tell me what you get. Where is the test statistic? It's negative 0.225. Does the test statistic fall in the rejection region? No. Which would mean we do not reject the null.
So that means there's no evidence whatsoever.
Is it? Well, what is it? Area above the test statistic, so we start at negative 0.225. Even before you start the problem, that part, you should sort of have an idea. Look at this picture. The test statistic is right here. We want to find the area above it. Yes? What is the area above the middle line? Area under the curve above 0. Statistics 2023. What is the total area under the curve?
1.
1. So exactly half. How much do we have? 0.5. So 0.5 on that side, 0.5 on this side. So if we have 0.5 area there, and I'm adding a bit more, so whatever answer that I get has to be bigger than 0.5. Agree? So start at negative 0.225. And at E99, and the degrees of freedom is 8.
This might be a really dumb question. I thought if the first value was negative, then E99 would also be
It depends on the test. That's not how it works. For a right tail test, it is the area above the test statistic. For a left tail test, it's the area below the test statistic. If this were to be a left tail test, and you'd start at negative E99 and go all the way up to T, area below the test statistic. See the difference? What is that answer?
586.
0.586. 2. Is it bigger than 0.5? Even before we started doing this, we had an idea that it has to be bigger than 0.55. Okay, is that p-value less than the alpha that we set at the very beginning? No. P-value is greater than 0.1, which is 10%. At the onset, we wanted to say, well, the maximum amount of error under the null that I'm willing to tolerate in rejecting the null is about 10%. But what does the data tell us? Well, under the null, the data is telling us if I concluded that I reject the null based on the evidence that I have, the probability that I'm going to be wrong is 58.62%. Would you make a conclusion knowing the fact that there is a 58.62% chance that you could be wrong? No, that is not very smart. Okay? So we should not be rejecting the null. So we just say, okay, the null is what we have. Mu1 is either less than mu2 or mu1 is equal to mu2. Clear? Can I erase this? This is part B. We have the critical value. We have the standard error from the test itself. And what is the value of the standard error that we had from earlier? 9.09. 09, right? Or 909.
9-1.
Okay. We have the critical value, we have the standard error. What do we need to find in order to find an interval? Margin of error. How do we find the margin of error? We multiply those two. Which is 70. No, 18.42.
427.
We'll call it 18.43. Good. Based on the interval, could we conclude that mu1 is greater than mu2 statistically? In other words, that mu1 and mu2 are different from each other. Last time when we were doing intervals, we said that mu1 and mu2 are statistically different if 0 doesn't fall in the interval, right? Clearly, 0 falls in this interval. So from a statistical standpoint, mu1 is not statistically different from mu2. If mu1 is not statistically different from mu2, is it logical or reasonable to conclude that mu1 is greater than mu2? No. Do you follow? So, if you recall last time, I said whatever information that we get using a confidence interval can also be obtained using a hypothesis test. And most statistical software, when they give an answer for a statistical test, they will also provide you with an interval. Does that make sense? So your homework assignments might ask you to do a test and find an interval also. It is very similar to a t-test, but we use this when sigma 1 squared and sigma 2 squared are known. That is, okay, what are the key differences? The test statistic do you see I'm using the same formula? Only this time I'm calling it as Z instead of T. Standard error formula what did we use previously? We used the sample mean, S1 and S2. But here, since the population variances are known, we just take those values from the problem and put it in here. Good? The distribution is standard normal. So instead of using inverse T and TCDF to find the critical value and the p-value, what should we use? Huh? Do you follow my question? Last time it was T distribution. Now it is standard normal. So instead of using inverse T and TCDF to find critical values and p-values, what should we use this time? Inverse norm and
Normal CDF.
normal CDF. Very good. So the process is exactly the same, but the only difference, or subtle differences, are that we use this formula for standard error, where sigma 1 squared and sigma 2 squared are given in the problem. And instead of using inverse T for the critical value, we use inverse norm. Instead of using TCDF, we use normal CDF. Good? That is called the Z test. Procedure is the same.